Okay, this is a further maths question from the last GC. Please, if you like my videos, send it to your friends and colleagues or whoever you know might need this for the exam. I think the further maths will be in a few weeks' time for 2025. Why? So this will really help them. Now here's the question. If 35% of the bulb produced by the machine are defective, find the probability that out of 4 bulbs chosen at random, 1 will be defective. Okay, for a binomial probability question, the first thing you want, there are things you want to take out. Your P, your Q, your N, and your R. Once you have this things right fully, then you're good to go. Remember, the key word here is defective. Defective. Now, P is the probability that of getting, you understand, of defective. The probability of, if we have 35%, listen, if we have 35% of the bulbs produced by machine are defective, that was the probability of the production. 35%, that means 0.35. So our P is going to be what? 0.35. Now, our Q. Q is the reverse, not defective. If the probability is 0.35, what the probability of producing a not defective bulb is what? 1 minus P. Write it here. 1 minus P. Or you can use what? Subtract 1 from your what we get 0.65. 0.65. So this is the probability of getting a defective bulb. 0.65. 1 minus 0.35. Get 0.65. So this is the probability of getting the defective bulb. Remember, I said 35% of the bulb produced by a machine are defective. So if 35% are defective, that means the probability of getting a defective bulb is what? 0.35. Now, probability of getting a not defective bulb is what? 0.65. Or you say 1 minus P, which is what? 0.65. Now, your N will be number of trials. Number of trials. Number of trials. And for this case, how many times? Probability that's out of 4 bulbs chosen. So the number of trials will be what? 4. Out of 4 bulbs chosen. Number of trials. 4. Out of 4 bulbs chosen. That at random, 1 will be defective. Now, your R will be what? Successes. N number of successes. Success. Or let me write number of success. Number of success. Your N, and in this case is what? 1. What if they said 4 boxes at random that 2 will be defective? Our R will be what? 2. You understand? The success you want. This is the number of times. N is the number of times. And R is the number of success. What you actually want to get. Do you understand? So, given this information, the formula to this is NCR P. Remember, P is the probability of success. And our success is what? Is R. Remember. Times Q. Q is what? Not successive. Is it not true? And it's what? N minus R. Remember, if you subtract this one, it's what we're going to get. Is it not the failure? Yeah. If you want to get 1 success, that means the rest will be failure. Is it not true? If you pick 1, that means 4. Out of, so that R will be our number of success. P is the probability of success. Q is what? Number of not being successful. And this is the probability of not being successful. And this is the number of not being successful. N minus R. So this information, using this, we are going to get our value. N choose R. Use your calculator. Put your calculator. Remember, N choose R is what? N is what? 4. 4C1. Remember, if you want to express this in the mathematical form, you go down what? N factorial over N minus R factorial R factorial. Which is what? 4 factorial over what? 4 minus 1 factorial, then 1 factorial. Now, if you solve this, I would like to do that is 4 times 3 factorial. Why did I stop here? Because 4 minus 1 is 3. Remember, this is factorial, so this is 3 factorial. Then 1 factorial is just 1 times 1. So if this cancels out, you're going to get 4 over 1, which is what? 4. So if you punch your calculator, 4 choose 1, your calculator. If you punch, you're going to get 4. What did you get? If you punch your calculator, you're going to get 4. So this is just the mathematical expression of that.
Excuse me, sir. Sir, please can you hear me explain the factorial again?
Okay, 4 combination 1. That's what I meant. I just said choose. 4 combination 1. So this is what it means. Let me use another value to explain. In case where you're giving 5 combination 2, let's express that. It's going to be what? 5 factorial. Let me write it here. Remember, this is in terms of NCR. Where N is 5, R is 2. How will you express it? N factorial over what? N minus R factorial R factorial. If we were to replace that with the values that you were given,
5 factorial.
it's going to be what?
5 factorial.
5 factorial over 5 minus 2 factorial and 2 factorial. Now, 5 minus 2, this is 3. That means this means 3 factorial. Isn't it?
Yes.
3 factorial. So I'll just stop. 5 factorial means 5 times 4 times 3 times 2 times 1. 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 2 times 2 times 1. So 5 factorial will be 5 times 4 times 3 factorial. Why did I stop here? Because I have a 3 factorial now. That will do what? Cancel out. So 3 minus 2. 5 minus 2 is 3. That's 3 factorial. So I have the 3. Remember, there's a factorial here. Then we have 2 factorial, which is 2 times 1. So 3 factorial cancels 3 factorial. 2 cancels what? 4. 2. 5 times 2 is what? 10. So for this case, you're going to get a 10. If you punch your calculator, you do 5 combination 2, you should get a 10 in your calculator. So this is just the illustration. So let's get down to our question. Now we said 4 combination 1. 4 combination 1. We have that value already. 4 combination 1 is 4. Like I said before, n over n minus r factorial and r factorial. Where n is 4. 4 factorial over 4 minus 1 factorial and 1 factorial. 4 minus 1 is what? 3. So we have a 3 factorial. So it's going to be 4 times 3 factorial over 3 factorial times 1 times 1, which doesn't matter. So our value is what? 4 factorial. Okay, 4 combination 1. We got our answer as what? 4. So now we want to enter these values. Remember, what's our P? Remember, this is the formula. N is 4, R is 1. What's our P?
0.35.
Our P is 0.35. Always to power R. What's our R? 1. What's our Q?
0.65.
0.65. Always to power N minus R. That is
4
N minus R. 4 minus 1.
That's 3.
3. The idea is that these two must give you the sum of this. The sum of this must give you this. So let's continue.
Hey.
So we have 4 combination 1 is what? 4. 0.35 raised to power 1 is what? 0.35. Now 0.65 raised to power 3. What should we have there? 0.65 raised to power 3.
That's 0.274625.
0.65 is 0.274625. 0.274625. Alright, multiply everything through. What do we have? 4 times 0.35 and
0.384475.
0.384475. So this is the probability. You understand? The probability when x equals to 1. This is the probability. Are you getting me? So if you multiply it by 100, you should get what? Multiply by 100, you should get what? 38.4%. That is the probability of getting a 1 defective block out of 4 random picks. That is the probability. Remember the formula. NCR. Q is the power R, Q is the power N minus R. R is the number of successes. So the probability where x equals to 1 is this.